Hello, so we're going to have a quick look at three definitions that are important to have in the back of our minds. Now these are going to make more and more sense as we do more maths, but we want to introduce them now so we have the rough idea of what they mean, and they're going to become more and more important as we do more complicated maths as we move on. Now, our three rules are called the Commutative Rule, the Associative Rule, and the Distributive Rule. The most important one in practice is going to be the Distributive Rule, but we're going to start over here with our Commutative Rule, and it's very straightforward. All it means is, does the order matter? Does the order of our operations matter? So what do I mean by that? Well, if we cast our minds back to sets, and we had A union B, we found A union B for a bunch of different sets, and we found that it was the same as B union A. It didn't matter which set we wrote down first, because B union A is the same as A union B, and likewise A intersection B was always the same as B intersection A. So we always found that those two were going to be the same as each other. So that is an example of commutative operations, stuff that we can do, an operation, where the order doesn't matter, commutative. Now, can we think of another example of commutative type operations? Well, if I had 3 plus 2, that would equal 5. And if I had 2 plus 3, that would also equal 5. So that means that addition, or that's an example of addition being commutative. But not everything is commutative. Sometimes the order in which we write things matters. So if I had 3 minus 2, that would equal 1. Or if I had 2 minus 3, that would equal minus 1. Now we haven't done negative numbers very much yet, so don't worry if you're not too confident with that. But you can see that we end up with different answers. So subtraction, minusing numbers, is not commutative. The order in which we write the numbers is very important. So that's commutative. The order of what we do doesn't matter if it's commutative, and stuff like union and intersection and addition are commutative because the order in which we write our numbers doesn't matter. Associative, to associate means to group together, and so the associative rule is about how we group together the sums that we do. So if we had 3 plus 5 plus 1, we would be able to do that as a sum, and we could say we could group our left hand side together like we usually do. We usually do the first two terms on the left when we're doing our adding up. So we'd have 3 plus 5 is 8 plus 1 from here, and then 8 plus 1 is 9. Or we don't usually do this. We don't usually do this, but we could start on the right hand side. We could have 3 plus 5 plus 1, and we could group the stuff together on the right hand side instead of the left as we usually do, and add this together first, and we would end up with 3 plus 6, and we add 3 plus 6, and we also get 9. So this is an example of the associative principle, or the associative rule. Likewise with multiplication. If I have 5 by 2, that is equal to 10. Or if I have 2 by 5, that is also equal to 10. It doesn't matter which one we write first. But again, that's not true of everything. If I had 5 minus 4 minus 2, let's see what would happen with my grouping. I could do my left-hand side first, and I would have 5 minus 4 would be 1, and then minus 2. Again, we haven't done negative numbers very much, but that's going to end up being minus 1. Or I could have 5 minus 4 minus 2, and I could group it together like this, and I would end up with 4 minus 2 is 2. Minusing 5 from 2, I would end up with 3. So minus 1 and 3 are not the same. So the order in which we break up or group our minuses does matter, but we can see that it doesn't matter when we have addition or multiplication. So that's the associative rule. And again, you'll be doing a lot more maths like this where you'll get confident with how to break these things up. This is just to have it started in your head for when we're doing the problems we're going to do with BIMDIS very soon. Now, the most important idea here, and this is going to be really, really important at the end of the year, is called the distributive rule. And if it doesn't make sense right now, it will when we come back to it later on in the year, but we're going to give a go at it now and we're going to build on it later. So, if I have something like 3 by 5 plus 2, if I have a sum like that, the way that we are going to do it almost all the time is to do the addition in the brackets first. And we'll get 3 on 5 plus 2 is 7. And then we will have 3 by 7 is 21. But from time to time, and when we come to algebra in particular, there's going to be another way that we can do this. We know that multiplication means that we can have groups of things. So this can also be thought of as having 3 groups of 5 plus 3 groups of 2. 3 groups of 5 plus 3 groups of 2. And that will give us 3 by 5 is 15. And 3 by 2 is 6. And that's going to end up being 21 as well. So this is going to be very, very important later on in the year, that we can break up our sums the way we usually do using BIMDIS, or we can break them up this way, where we are going to say we have 3 5s plus 3 2s. This is going to be so important later on. But for right now, we're just introducing it so that you're comfortable with the idea a little bit, and then when we come back to it later, you're going to be even more confident with it. So that's our commutative rule, where the order of operations doesn't matter, the associative rule, where we can group our problem in whichever way we like, and the distributive rule, which is where multiplication can be spread out. So the 3 can be spread out to the 5 and the 2 in multiplication with brackets. And again, we're going to come back to this later in the year.